everybody. Thanks for coming to the 6 o'clock edition of the class. I guess it's not class, office hours, whatever you want to call it. I'll give a few minutes for people to trickle in before we get started, but you want to say hi if you're here and in the chat, just so I can see who's here. But yeah, the plan for today, tonight, whatever you want to call this, we'll just start with question 1 of the review packet, and we'll just see how far we could get in the hour. Okay, we're obviously not going to finish the whole thing, but we should get a few questions in. I'm hoping 10, maybe more than that. Okay, nobody said hi. That's fine. All right, well, we'll start with question 1. Oh, okay, we got a couple of highs. Nicole, Jax, good to see you. Good to see you. I mean, I guess we could do a simultaneous sip. I don't have coffee because it's nighttime, but I do have this cup of water, Wake Forest. So if anybody wants to join the simultaneous sip, you can do so now. It's just not the same without coffee. Okay, so are we good with starting with question 1? Nicole, excellent. Anyone opposed to just starting with 1 and working our way down? Start with 1 and just see how far we can get. Okay, so we want to find. Oh, this is not a good marker. Zach Davidson is in the chat, joining in on the simultaneous sip. That's always good to see. X squared plus xy plus y to the third equals 1. And it says find y double prime at the point where x equals 1. Okay, so does somebody in the chat want to just kind of give a basic, couple word answer of how we're going to solve this question? Like, what technique do we use to solve this question? You don't have to go through all the details, but just, what section is this from? Yeah, Jax, implicit differentiation. We're going to take the derivative of both sides with respect to x. And so when we take the derivative of y, we'll have a y prime involved. Okay, so let's just work through this. The derivative of the left-hand side, derivative of x squared is 2x, plus the derivative of x times y. Well, that's a product. So we should use the product rule. So it's the first times the derivative of the second plus the derivative of the first, which is the derivative of x is just 1 times the second. Okay? And now I'll keep going, but I'm going to ask you, what do we do after we do this first step? What's next? So the derivative of y to the third is 3y squared times y prime, right? This is the chain rule we're doing here. Bring the power in front, drop the power by 1, and then multiply by the derivative of the inside, which is y prime, and then is equal to the derivative of 1, which is 0. Yeah, so we'll keep all the terms with a y prime in it on the left. Everything else we could bring to the right-hand side. Well, Nicole, you're kind of right. Everything else we want to get onto we want to keep all the y primes on one side and everything else onto the other side. So now we can factor out a y prime. And we get sorry, we should factor out a y prime, x plus 3y squared. And we get y prime is equal to minus 2x minus y over x plus 3y squared. All right, now where do we go from here? We want to get y double prime. And so we take the derivative of both sides, right? So take the derivative of the left-hand side, we get y double prime. Now we have to take the derivative of the right-hand side. This is a quotient. So Jared, you're right. Use the quotient rule. So it's the bottom times the derivative of the top. Derivative of the top is minus 2 minus y prime. Minus, okay, what I'm going to write here is still going to be in the numerator. I just don't have the space. I'll just write it in this direction and erase it in a second. Minus the top times the derivative of the bottom. Derivative of the bottom is 1 plus 6y y prime. All over the denominator squared. Okay, and so where do we go from here, right? It says find y double prime at the point where x equals 1. And if you're unsure, just maybe throw some question marks in the chat or, yeah, plug into 1. You're right, Jared. And since there's such a delay, I'm going to just answer it for you. We plug in 1 into our original function to find the y value. Okay? But notice we're still going to have to find the value of y prime at some point. So we'll have to find our point and plug it into y prime. Rena, what you said is we could do that. And it's not going to be wrong. It's just going to be a little bit messy if we do that. So what we'll do is we'll plug in the point into y prime, and that value will substitute for y prime. Is it easier to eliminate the denominator and use negative exponent instead of using the quotient rule? Maybe. You would have to still use the product rule, and you would have to use the chain rule. So if you prefer quotient rule, then use quotient rule. If you prefer using both product and chain, then you could switch it to a negative exponent. But I don't think that's, I think the quotient rule is probably just easiest. All right, so let's find the point. So we substitute x equals 1. So 1 squared plus y to the third is equal to 1. And so this is y to the third plus y is equal to 0, right? We subtract over the 1. Y times y squared plus 1 equals 0. So y equals 0, and this has no solution, right? Y squared plus 1 equals 0 has no solution. So the point is 0, 0. And so now let's find y prime of 0, 0. I mean, so we could do what Rena said and substitute y prime for this thing and put it into our equation, then just plug it in all at once. But I think we'll see that my method is better. I don't like this. Oh, the point is not 0, 0. The point is 1, 0. Okay, and I'm going to do it again. Try this again. Okay, sorry. I was nervous because we were going to divide by 0 if we plugged that point in, and I would not have given that to you. Okay, I'm sure you all have noticed that, and just for keeping quiet. So y prime of 1, 0 is equal to negative 2 over 1. And so y double prime of 1, 0 is equal to 1 times negative 2 minus negative 2. Oh, there's more of our numerator here. This whiteboard is not very big. So that's this part minus I'm all over the place right now. Minus negative 2 times 1 plus 0, which is 1. All over is 2. Okay, so basically what I did in this last step is I just plugged in, for all the x's, I plugged in 1. For all the y's, I plugged in 0. And for all the y primes, I plugged in negative 2. And then just do some algebra, and it works out to be 2. Any questions on that, or can we move on to question 2? I'm going to need a little bit of feedback in the chat, just because, you know, I'm talking to a computer screen at this point. But while you're typing in any questions or comments, I'll start writing out the next question. All right, you can figure out what the rest of that word is. There's just not space. So, so y is equal to arc sine of 3x squared minus 6x plus 4. You want to find y prime using implicit differentiation. Okay, so how do we get started on this question? I'll leave this up while you guys are commenting. Yeah, so we'll evaluate the sine of both sides. right? Because we don't, I mean, sure, you could look up on like Wikipedia or whatever, how to take the derivative of arc sine, but don't do that. We should use the techniques we discussed in class. So we're going to evaluate the sine of both sides. And so the left-hand side becomes sine of y. The right-hand side becomes sine of arc sine of 3x squared minus 6x plus 4. So that's just 3x squared minus 6x plus 4. Is arc sine the same thing as sine to the negative 1? It's the same thing as the inverse of sine. It is not. So arc sine of x is not equal to 1 over sine, but it's the inverse function. The notation for trig functions is just so terrible that that's why we use arc. It's like, so sine inputs an angle and outputs the ratio. This inputs a ratio and outputs the angle. So it reverses the function. But yeah, you may see the notation sine to the negative 1, and it means the same thing. So from here, we'll take the derivative of both sides. Derivative of sine of y is cosine of y times the derivative of the inside, which is y prime. And the derivative of the right-hand side is 6x minus 6. Okay, and so we get y prime is equal to 6x minus 6 over cosine of y. So since our question started with writing y as a function of x, it'd be nice if we ended with the derivative as a function of x. So we want to do something with this cosine of y. So my question is, how do we deal with the cosine of y? Yeah, so we'll set up a right triangle, right? We have this equation that says sine of y is equal to 3x squared minus 6x plus 4. This tells us all the information we really need. Right, so sine inputs an angle. So our angle will be y. And so sine of y is the opposite over the hypotenuse. We could treat this as 3x squared minus 6x plus 4 over 1. And then the question is, how do we find this side length, which we could call a? Yeah, Nicole, Pythagorean Theorem. So we'll use the Pythagorean Theorem to solve for a. We have a squared plus, and now don't multiply this out. Just leave it as something squared. 3x squared minus 6x plus 4 squared is equal to 1 squared. Solve for a. We get a is equal to the square root of 1 minus 3x squared minus 6x plus 4 squared. Okay, so our adjacent is this. So cosine of y is adjacent over hypotenuse. And so now we could sub that into our equation for the derivative. So y prime is equal to 6x minus 6 over the square root of 1 minus 3x squared minus 6x plus 4 squared. Any thoughts or feedback? Questions? Concerns? Anybody moved to tears about how beautiful this question is? I was the first time I saw it, so you don't have to be ashamed. But if not, then yeah, Zach, if you're it's possible that you haven't seen these types of questions yet. If you first, not all teachers are obsessed with the derivatives of inverse trig functions like I am. So it's possible you'll just never even see these. But I think it's nice because it forces you to use a little bit of trigonometry that people tend to forget. Okay. Yeah, so now let's move on to these related rates questions. We got a bunch of them. I'm not going to write out the whole question, but I'll read it. Yeah, and I'll draw along with what's being described. The top of a ladder slides down a vertical wall at a rate of 0.15 meters per second. Okay, so we have a ladder against a wall. It's sliding down, and it's also sliding away. We'll call the height, how far the ladder is up the wall, we'll call that y. And how far it is from the bottom, we'll call that x. And then just to complete the alphabet, we'll call the length of the ladder z. Okay, so we're dealing with this sort of ladder problem. The top of the ladder slides down at a rate of 0.15 meters per second. So y is changing. So dy dt is changing at a rate of 0.15 meters per second, and it's decreasing. So it's negative 0.15. Okay, the next sentence says, at the moment when the bottom of the ladder is 3 meters from the wall, so we'll have, at some point we'll use x equals 3. It slides away at a rate of 0.2 meters per second. How long is the ladder? So what are we trying to find here? Yeah, we're trying to find z, or the hypotenuse. Yeah, so find z. Okay, so this is a related rates problem, clearly. Is there a way to relate all of these variables? Well, it's a right triangle, right? So x squared plus y squared equals z squared again. Okay? And so what we could do, we're not going to plug in any information yet. I know a lot of people get in this mindset of, oh, we have a bunch of variables. Let's plug in as much as we can before we take any derivatives to make it easier. It's going to just make the question not work. Okay? So you have to take the derivative first before you could plug stuff in. Right? Because if you were to plug in x equals 3, that makes it seem like it's a constant. But it's not. It's changing as the ladder falls. X is changing. So we have to make sure we don't plug anything in until we're ready for it. We're trying to find z. Okay, so let's take the derivative of both sides with respect to time. Right, everything's changing with respect to time. So 2x dx dt plus 2y dy dt is equal to, well, I guess 2z dz dt. And so my question before we move on is, what is dz dt? So how much is the length of the ladder changing throughout this question? Yeah, Zach, it is constant. So the derivative of a constant is 0. So it's not changing at all. Yeah, so our right-hand side of our equation is just going to be 0. Right, it's 2 times z times 0. We want to find z still. So maybe this isn't going to help us out at all, except we will be able to find y, right? We know x, we know dx dt, we know dy dt. So let's find y. So 2, x was given to us as 3. Dx dt is 0.2. Okay, and we could solve for y. Space is at a premium right now, so I'm just going to do the algebra in my head. We get y equals 4. I also have the answer written out, so I didn't actually do any algebra in my head. But you could solve for y here. You'd see it's equal to 4. And now how do we get z? Yeah, Pythagorean Theorem again. So we could use our equation up here. The way that all the variables were related, we could, we should use this. So 3 squared plus 4 squared equals z squared. You get z equals 5. Okay. So here we weren't able to find z once we took the derivative, but we were able to find y, which helped us find z. So sometimes you have to take a little bit of a sidetrack to get to the answer, but it worked out. All right. Well, if you have any questions, just type them into the chat. I'll move on to this next one. So this is number 4. A spotlight on the ground shines at a wall 12 meters away. You know how you could tell that I stole these questions is that they use the metric system. I would never use the metric system if I wrote the questions. Okay, never mind. Okay, I actually may have written this question. So it shines on the wall 12 meters away. We have a wall over here, and it's 12 meters away. A man 2 meters tall walks from the spotlight, so we have a man here. And he's walking from the spotlight towards the building. We'll say maybe he's X. His distance away from the spotlight is X, but it's changing. He's 2 meters tall, though. I should not have drawn this guy with actual body parts. Oh, he's 2 meters tall and he's not growing at all. So we could write that in as 2. He's walking at a rate of 1.6, and X is increasing, so it's going to be positive. The question is, how fast is the length of his shadow on the building decreasing when X equals 4? So let's call this, okay, I'm changing the picture a little bit. So here's his shadow. Let's say the length of his shadow is Y, right? Because if he was standing here, the spotlight, this would be his head, his toes would cast a shadow down here. It wants us to find dy dt. So this guy is 2 meters tall. Right, because you could imagine as he's walking, I mean, this is perfect because I got my spotlights here to brighten the board. You could kind of see what's happening as he walks. The shadow gets shorter and shorter. So how are these variables related? So I'm going to move this arrow, get it out of there, because it's not terribly important. Yeah, we could make some similar triangles. And since there's such a delay, this is where I'd like to ask you in person how to do this, but I'll just explain. We could make a relation. So this small triangle here is similar to the big triangle. Okay, so X over 2 is equal to 12 over Y. So these are similar triangles. Okay, now where can we go from here? Yeah, let's cross multiply, take the derivative, and see what happens. Okay, so xy is equal to 24. Take the derivative of both sides, right? Because we want to relate rates, so we need some rates. The derivative of the left-hand side, even though we're not in a section called the product rule, we still have to recognize when we use the product rule. And here's one of those cases. So it's the first times the derivative of the second plus the derivative of the first. Here we're taking our derivative with respect to time. Okay, so the derivative of x is not 1, it's dx dt. So x times the derivative of y plus derivative of x times y is equal to the derivative of 24. Well, the derivative of a constant with respect to any variable is just 0. And so now let's plug. We know dx dt. That's all the information we have. So how do we get y? We need to find y somehow. Does anybody have any ideas of how to get y? Yeah, we could use, well, either one of these equations. This one's probably easier. That's one that you recommended? Yeah, so let's just use the xy equals 24 equation. So over here, we know that x is equal to 4. So 4y equals 24. Y equals 6. All right, so now let's just plug everything in. So 4 dy dt plus 16 times 6, or 1.6 times 6, is equal to 0. Solve for dy dt. It's negative 9.6 over 4, which is negative. What is this? This? Okay, well, let's just make sure we read the question correctly because we're not getting the same answer I got. But, I mean, we're okay. How fast is the length of his shadow on the building decreasing when he's 4 meters, not from the light, but from the building? Okay, so we made a little bit of a mistake, but it's not going to change much. The process was good. He's 4 meters, so it's not x equals 4, but this length here, which is 12 minus x, is equal to 4, which means x is equal to 8. Not really going to make a difference. So we just misread the question. Okay, so if the question said he was 4 meters from the light, then what we did originally would be good. But we misread, or when I say we, I mean, I'm talking about, I misread it. Yeah, so he's 4 meters from the wall, which means his distance from the wall, which is 12 minus x, is equal to 4, which means x is 8. I somehow gained a viewer during that catastrophe there. Are we good with this question, or should we talk about it some more? I feel bad that I misled you at first, but the process is right. We used similar triangles and took their derivatives, and yeah, Jax, he's 8 meters from the spotlight, 4 meters from the wall. That's what the question says, right? Yeah, he's 4 meters from the building. So yeah, he's 8 meters from the spotlight. Okay. This next one's easy. Should we do an easy one or a hard one? Well, they're both actually pretty easy. Wait, what the heck? Let's see. Okay, yeah, this next one's not as easy as I said, but it's pretty easy. Okay, so the area of a triangle with side lengths A and B and contained angle theta is A equals AB sine theta. That's a trigonometry fact for you. Okay, if A equals 3, so A and B are constants here. A equals 2, B equals 3. And theta increases at a rate of 0.2 radians a minute. How fast is the area increasing? When theta equals pi over 3. Here A and B are constants. Is there a... Oh, is there? Oops. Yeah, again, not terribly important for the question. It's just a constant, but yes, there should be a 1/2. Gosh, I got to read these examples while I'm writing them down. I'm going blind or something right now. Yeah, so A equals 1/2 AB sine theta. Guess what I found? What we found there would be like the area of some sort of parallelogram. Yeah, so this one's straightforward. We just take the derivative of both sides and plug in our values. So dA dt is equal to 1/2 AB cosine theta d theta dt. Right, and now we just plug in all the values here given. Cosine of pi over 3 is what? I believe it's 1/2. And so the area of the triangle is increasing at a rate of 0.3 units of length squared per minute. Okay, one more related rates question. And then we could move on to linear approximation. A particle is moving along the hyperbola xy equals 8. As it reaches the point 4, 2, the y-coordinate is decreasing at a rate of 3 centimeters per second. Right, do we agree that this is all the information from that question before we move on? I've messed up the last two, so let's see if we could recover. Okay, well, I'm happy with this. Let's take the derivative of both sides. So the derivative of the first times the second plus the first times the derivative of the second. The derivative of the first times the second plus the first times the derivative of the second is equal to the derivative of the right-hand side, which is just 0 in this case. It's not always going to just be 0. It may be, but since we have a constant on the right, it is. All right, now let's just plug in everything we were given. So find dx dt. We know y. We know x. We know dy dt. All right, so we just plugged in this. These last two have been pretty straightforward. I think the first two were a little bit harder. But yeah, we were given the way the variables were related. We took the derivative and just plugged in all the appropriate information. All right, let's do one last question, and then we could probably call it quits. So it's use a linear approximation. Need a little bit of participation for this one. What bits of information do we need to find this approximation? I guess before we do this, what would you do if you were only given 1 point? You mean like one of the x or y values? So if we were only given, let's say, x equals 4, then you could sub that into this equation to get y equals 2. And similarly, if we were given y equals 2, you could sub it into here and get x equals 4. So if we weren't given both the x and y values, that's how you'd get it. Nicole says the parent function, and then we need an a value. Yeah, exactly. So our parent function will be f of x is equal to, here we're looking for 1 over 4.002, so maybe 1 over x is a good idea. And we'll use a, so this should be a value that's easy to compute without a computer or without a calculator. So for instance, we know 1/4. That's 0.25. So let's use a equals 4. And so we also need f of a. And we need f prime of a. So let's take the derivative. The derivative of 1 over x is negative 1 over x squared. And so f prime of 4 is negative 1 over 16. And so with all this information, how do we get our approximation? So 1 over 4.002 is approximately equal to f of a plus the slope times 4.002 minus 4. Yeah, so what Jack's typed in the comments is exactly right. That's our linearization. Basically, the idea is we're taking this curve, which looks like this, and we're just going to use this tangent line to approximate the values. That's kind of what's happening behind the scenes here with this formula. Yeah, so this works out to be 1/4 minus 1/16 times 0.002. Okay, and that's easy to compute. All right, so I'll stay around here to answer any questions you may have, but I think that's all we're going to do for tonight. Make sure to smash the like button before you leave. That always helps. But yeah, so the plan for tomorrow in class is we're just going to review. So look at the review sheet, figure out what the hard questions are, and we could go over the hard questions tomorrow in class. Okay, so that's the plan. You do have WebAssign due in 5 hours, so I don't think there's much though. So make sure you do that also, because that's worth some points. But yeah, so tomorrow in class will be just like this, but we'll pick the harder questions. We won't have time to just do them all in order. So are there any other questions? Zach, we'll see you later. Thanks for coming. Hope this helped. I'm currently stuck at 666 YouTube subscribers, which is an unlucky number for those superstitious people. I'm not worried. Not even a little bit worried. Nicole, you're welcome. See you in class tomorrow. Okay. I'm going to make dinner now. Bye-bye.